Okay, so yeah, Hart Ripley. I'm a solution architect at Mobia. Mobia is a solution integration company. Primarily, we're working in Canada, a little bit in the US, but focused on kind of some of these tough challenges for clients and finding solutions.
And my name is Matt LeBlanc. I'm a senior systems engineer at Avesha. And it's just a coincidence on the name. You may recognize the actor from Friends. I've been hearing that since my whole life, since we grew up in the same town outside of Boston. We'd like to start out by talking a little bit about some of the challenges that we do have. Now, Hart and I have been working together for a little bit, and one of the challenges that we do have these days is regarding networking around the cluster. Hart, you want to talk a little bit about this?
Yeah, sure. I can take it from here. Okay, so we're talking about networking. We're talking about clusters. Like, what is a cluster? Well, in this context, a Kubernetes cluster, right? Container platform, right? Just to kind of make sure that that is understood, right? I want to pose a couple of questions, really, just to everyone here. Anyone that's kind of playing in the Kubernetes world, running applications on Kubernetes, those types of things like that, right? How are you, like, have you run into challenges, sharing, securing clusters, communication between, we're showing two islands here, right? Let's think these are clusters, two clusters, one running in cloud, one running on-prem as an example, right? So how are we going to ensure that, if we have a single application that's running across these two clusters or running separately on these two clusters, that we can unify that, right? We can make it either highly available, we can make it, be able to fail over, kind of have a DR set up, those types of things like that. So really, how is everyone here kind of connecting, different workloads, I guess, different applications, making sure that, the management of these applications and the connectivity is simplified, right? Just something to think about, right? Any questions or any feedback, definitely drop that in there. We can have a look at that, but just kind of want to set the stage with, how are you going to connect your clusters and manage them securely, right? And that's what we want to talk about today, right?
So,
Multi-cluster management.
and what I have seen in talking to a few of the banks in Toronto, Montreal, and the New York, New Jersey area, is that oftentimes they're in a data center or they're in a cloud, and they keep those as completely segregated data points, right, or areas of information, because of the challenges is in securely sharing that data. So, one of the some of the challenges that you'll go through is you need to set up your cloud peering, make sure they can communicate, create those inbound rules, setting up your load balancing, configuring your DNS, and setting up your SNAT. I know, Hart, you spend a lot of time in the networking area.
Yeah.
Is this something that a lot of people, how much effort does it take to do all of this?
Yeah, there's definitely a lot of effort, especially if you're not, doing it as code, right? We talked a little bit about infrastructure as code, but when we're talking about, on-prem, AWS, Azure, Google, where are these container platforms running, right? We can't just easily connect them, right? If we have a platform running in one cloud and a platform running on-prem, right, there could be different teams managing the network stacks, right, or the network configurations across these
So,
two.
to use the analogy of the baking, or there are probably a few too many cooks in the kitchen, right?
Yeah.
You got to talk to SecOps, you got to manage firewall rules. Those who manage cloud A versus cloud B could be two different sets of people. So it's really hard to get through all, not only the technical side, but there's almost a little bit of politics as well, right?
There definitely is, and you got to also think about how quickly can you do this, right? Like, it could be a long process, workflows, requests, different policies need to be set up, those types of things like that. But if you look at some of the stuff on the screen here, we're also talking about, like, incurring cost, right?
Yep.
Like, we're going to have to set up, VPC peering. Well, that's not free, potentially, right? We could have traffic coming in and out, all these types of things like that, right? So it's, different methods of ingress, those types of things. So if we can unify that and make it easy to manage, then, we're abstracting kind of where it's running, maybe the different teams that need to actually help us or help kind of build those platform integrations, those types of things like that. So cost is definitely something that, doesn't come up as obviously here, but when we're creating, different things in the cloud, we always need to consider what's that going to cost, and is there a better way to do it?
I was listening at to a podcast recently, and they brought up, the cost of storage, cloud storage is actually fairly cheap compared to the cost of bandwidth. So, moving your data is another consideration as well. So that kind of leads us to the next slide, and I don't have a lot of slides here, but there's got to be a better way, right? And we are Mobia and Avesha are our partners, and we believe that there is a better way, and it's our we have an open source version of kubeslice, and then we also have the enterprise version. And kubeslice quite simply allows you to securely connect, manage, and monitor your connectivity to your clusters, and that includes any cloud or on-prem or with any flavored Kubernetes. It's deployed as an operator. Everyone needs to have that because you need to be able to deploy that code as deploy that application as code. And we use layer 3 networking, so that's low latency and a fast response. Hart, how is that connectivity usually done? Layer 4, 7?
Yeah, either or, right? There's lots of multi-cluster networking solutions on the market, right? Open source, enterprise, those types of things like that. But a lot of those require you to plan ahead, right? Either you're planning to use those solutions before you build a cluster, not after, right? There's considerations of networking and subnets and those types of things like that, where this is, we don't have to worry about that stuff here, right?
So you mentioned networking.
Yeah.
I've also talked to a few of those banks that also indicated that managing those IPs is another challenge. And pretty serious one. It was, again, back to the bank up in Montreal, Toronto area. So what Avesha does to get around this is we use a flat network, say 192 network, right? That is not routable. We have our, there's no NAT, and we're also able to get this done from an encryption standpoint. So it is secured. And of course, in a enterprise environment, you're going to need RBAC, very granular role-based access control to make sure that each of your operators has, or each person has, the correct access to what they need. So what does that all mean? kubeslice. Let's talk kind of a bigger picture. We all probably know what a namespace is, but I'm just going to step back just a little bit. I come from more the traditional IT side from a few years ago, pre-COVID. And so when I first heard of the global namespace, the thing that I thought of was like, think of this as a folder in a file system, right? It's just a construct of organization, and that's where we install our applications. So what we do is we will create what I refer to as a global namespace that will go across all of your clusters. So you can see that we've basically created a virtual cluster across, in this case, GKE, AKS, and EKS. And that makes management of your clusters, plural, much easier. So there are a few use cases that we can use for this. We can burst the cloud, which is, if you want to be able to, some customers will have a need to migrate, but that can be a little overwhelming. So you can start doing a burst to another cloud deployment, or you can start doing a partial hybrid migration, or one of our other customers, they are running a large gaming, multiplayer gaming platform. And they have a fixed amount of resources, CPU, RAM, storage, in their data center. And when they exceed that capacity, or before they exceed that capacity, they've made the choice of using kubeslice to connect to another cloud provider to extend for that burst, right? You got a lot of activity coming in, and now you can just extend your existing application to somewhere else. It's pretty much the dream of cloud, isn't it? We can also use kubeslice for multi-cloud database resiliency. I do another demonstration using PacMan, which we'll come back to in a minute, and basically allows us to run Mongo in a multi-cluster environment without having to manage all that ingress, egress, and all the other challenges in connecting your various clouds. Zero trust, right? You want to be able to segregate your data, and this is another way to do it. And then we have zero RTO, being able to recover very, very quickly. Or in this case, we can also use this for migration, which is what we're going to do today. And quite simply, I talked about earlier, if you want to connect your data center, this could be Red Hat OpenShift, this could be any flavor of Kubernetes, and you want to extend to the cloud, this gives you the means of doing this, right? Eliminate the need for lift and shift. You can do partial migrations. So what we have here, that is pretty much more or less the end of my slides. I have a little demonstration that exactly for the reason earlier that was mentioned, that sometimes things go wrong. I recorded this because, the code changed in the back end and it was broken, and I had to record it and make sure that it worked the first time. But this was live done today. The setup's pretty simple. We're using kubeslice. We're going to connect our 3 clusters, EKS1, GKE2, and AKS3. And then we're going to migrate the instance of PacMan and the Mongo database from GKE2 to 4. Now, the reason I chose to do this in GKE2 to 4, East US to Europe, was quite simply I didn't have to deal with these storage conversion, right? Because if you're using different storage types within one cloud versus another, you also do have to do a transformation. It's the shortest path, but we can do it. So if you wanted to move from any of the cloud providers to another one, we can certainly do that storage conversion as well. So we're going to be using kubeslice to recover PacMan on the other side in that GKE4. And each app's ran locally on the customer. I think of that as the PacMan, the game, is a stateless app, and the high scores are kept on Mongo. As a matter of fact, we have a primary replica is read-write, and then we have 2 secondaries that are read-only. And then we're going to migrate from GKE2 to 4. So let's get into our demonstration. So I do have this, as I mentioned earlier, I have this set up for a video. I'm going to narrate through this. It is 14 minutes, but we're going to skip around a little bit. That's why I recorded it, so we can kind of get through. So this is our kubeslice dashboard. As you can see, we have a global view, and we are looking at all the clusters associated with the Mongo slice that we created. So we have our EKS cluster, AWS East 1, our Google GKE cluster, West 1, and then our other Azure cluster. And then there's our GKE4. That's where we're going to migrate to. So let's get into it now. If we look around here, we can manage our clusters from the dashboard. Take a look at the clusters. These are the 4 that I was just referring to, 1, 2, 3, and 4. And we've created a slice. And that slice, called MongoDB slice, is sharing the MongoDB namespace amongst those 4 clusters, and with that one MongoDB namespace. So let's take a look at this from Lens. This is how I'm managing my clusters. You can see from the top left, EKS, that first one, 1, 2, 3, and 4. And let me just pause that for a second. So now what I'm going to do is I'm going to show you that this application's live, up and running. And I just clicked on the forward so you can see me playing. Point is not to watch me playing. The point is to get a score up on the board here. So we're in AWS EKS1, and I called it test 3. Look at the score, and you can see our score is up there. I'm going to do that 2 more times. So we're now in our Google cluster, GKE. We're also going to run, there's our PacMan app. You can see we're in GCP, US West 1. And now that I've got a large enough score, I can now just kill myself here. All right. So now we got GKE2 test 3. There it is. There's our data. Moving on. Last one, AKS. We're going to run PacMan. And again, just get a score up there. We're up in Azure on West US 2. And as you can see here, I think I have a score that's high enough. There we go. All right. Score 300. That should get me to the top of the leaderboard. Call it AKS 3, test 3, save. All right. And there is our score. So now we're going to do the migration. Now, the migration you would think would be a little challenging, but we've made it fairly easy. First thing we are going to do is we're going to go over to our EKS cluster. That's where the Avesta kubeslice is running. So that's where we're going to run our commands from. So I'm running in EKS. And we're going to run the migration slice YAML. Now, essentially, I'm just going to fast forward a little bit. That migration slice essentially is saying, hey, we're going to use that PacMan migration slice and that namespace. And that's kind of defining our migration. And then we have our migration job, which is basically where we actually are going to move from cluster 2 to cluster 4. So let's start that migration slice. Now, rather than want you guys watching paint dry, I'm going to fast forward just a little bit and get a status on what's going on over here. So currently, what that last YAML did was it was able to deploy Valero. So we're using open source code. We're using MinIO as our bucket repository, and it's basically setting those up right now. Now, we just got, it's almost done. And we're now going to run the migration job itself. So we're going to go back into EKS. We're going to run the migration job itself. And this is where I'm going to fast forward after we hit the carriage return here. All right. So we have started that migration job. Now, essentially what it is doing is going to take a backup of GKE 2, our second cluster, and then we're going to do a restore onto the second cluster. I'm going to fast forward a little bit, and let's see. Oh, yeah, actually, I'm now checking a status to see what the progress is. You can see that it is in the process of backing up those 39 items, and once it has completed them all, you'll then see, fast forward a little. All right, so now we are done. Let's go over. That's for a little bit more. Oh yeah, we're gonna get a status of the restoration, and we can see that it has completed. And the only thing we're waiting for now is for that application and the database to come back up. So fast forward a little bit longer, and the application has come back up. You can see we are on GKE 4, that European one. And we just fast forward a little bit. Got to get top of the leaderboard there. I got my score of 380. And hopefully that's it. GKE 4, test 3, save the high score. And as the magician says, is this your card? So that's pretty much all I have for a demo. Now, what I would like to continue doing is really just kind of talk about, how this applies. As I mentioned earlier, we've been talking to a few banks, and they have challenges of migration. They have challenges of running out of resources. Some of those banks on Wall Street, they have data centers that they've invested in New York and New Jersey, and getting it's not just the resources. When I say resources, I'm talking about people. They don't have enough bodies to do the migration to get off of the investment that they have in their corporate data centers to be able to move to a cloud. But this would be a strong tool to be able to use for migrations, bursting, data resiliency, a lot of different use cases that we're actually going out to find out right now. This also applies to Red Hat, which is also one of the big players that we see out in the market, especially for the on-prem environment. So if you want to be able to migrate your data from, let's say, the AWS, and you want to pull it back on-prem, this would be another way to do it. Hart, do you have anything to add before we wrap up?
No, I think that's good. I think the one thing though that I just definitely want to highlight is we can look at this not from an entire cluster perspective, but we can secure applications, right? We can specifically hone in on, we don't have to encrypt the whole cluster. We don't have to deal with the networking at a cluster level. We can say we want this one application to either be migrated or highly available or secure across multiple clusters, right? I think that's one of the main points there to say, I see this a lot where everyone's looking to, we need to encrypt all the traffic within the cluster. right? And that may not be always warranted, right? Obviously, there's some overhead and some other considerations there. Let's say, okay, we need to make sure that the application talks securely, right? So the team that's running it, doesn't have to worry about any of that stuff, right? Using something like this, we have our overlay already. We have all these types of things where we can say wherever our application's running at the namespace level, we have that encryption out of the box. I think that's something we definitely want to highlight is a very key point here.
Exactly.
Yeah.
Well, thank you very much, everyone, for your time. I appreciate, if you have any questions, feel free to reach out to Hart and myself. We're both available on LinkedIn. Matt LeBlanc, Boston, and Hart is up in the Toronto area.
Yeah, it looks like there's one Q&A there, Matt, if you can see that.
Oh,
Just
yeah.
before we jump off here.
Lost my Zoom screen. You want to read it?
Yeah, it's just in the past we did a zero downtime migration and a hybrid on-prem native app to AWS ECS using Cloudflare. If I understand correctly, kubeslice is Kate's native and may not be the right tool for a hybrid environment. So it sounds like some containerized, some not containerized, or ECS, being kind of more
Oh,
of
yeah,
a
yeah, with ECS not being,
yeah, exactly, like a
yeah, it's,
platform per se, right? So
yeah, not all containers are Kubernetes. It's kind of like all thumbs are fingers, but not all fingers are thumbs. Yeah, it's a valid point. This would not be applicable to anything that is not Kubernetes. This is a Kubernetes native solution, and is available on github.com/kubeslice. And there is a open source version that is command line only, so you wouldn't get the dashboard to manage your environment.
yeah, I think maybe the one point there too, Matt, to that is when we're talking about managing this stuff as code, if it is all Kubernetes, right? Considering in this use case here, we can manage kind of these backups, these restores, these failovers, all these configurations across clusters as code, right? We're not saying, like, back to the earlier point where we had all these different cloud environments, right? If we need to stand up different integrations, here we can say, okay, we're going to deploy, kubeslice across all these clusters. And then we have our repositories where our code is to define, how the application is secured, how it's deployed, how it's failed over, those types of things, right? In a unified way.
Exactly.